So it's nothing. This is a very simple architecture. You put your inputs, which is all your sentence or all your context. I go and create an embedding of that. Then I add where is this position in the word, in the sentence. I can do that because I know you gave me the sentence. So I can say this is first position, second position, third position, this token. So I have converted into tokens. The tokens are converted into embeddings, and I have superimposed the position. They learned that adding position was making them even more accurate. So they added this. Then they have this attention layer, which is nothing but just telling you which embeddings are more important compared to this embedding on each one of them. And then they have a neural network. This is what we learned last time, which is just taking this information, taking this as a feature engineering as an input, these metrics, after this multi-head attention has added that context of what is important, which tokens are important to what, that goes to a neural network. And what it splits out eventually is your probabilities of all words of English dictionary. And then the next word, which is the highest probability. And if I can do that again and again, I'm done. And GPT uses just this part of so this is an encoder decoder architecture. Here you use an encoder to encode this information. This is the decoder that you use to generate the next word. In GPTs, we don't use this piece. We only use this piece. So this is not used. You only use the decoder part. And now you can generate next sentences as output probabilities. So that's the architecture. One gotcha that we have is the Financial Times is, so this is the summary. You take the words, you pass through tokenization, you got tokens, you created embeddings. Embeddings allows you to figure out what words come together. Then you put self-attention, which allows you to see where to pay attention, how is each other related. And then you got some encoded output. And then you just take that and pass it to a neural network to figure out what is the best next word probability. And that's how transformers work. This might be a little involved. So I have more links for you. If you want to deep dive, then you can go here. I have put a lot of resources, which I have used to learn this. I think this one is what I showed you today. This is a great video to watch. This explains all the math, everything step by step, what's happening in query key value. So watch this. And if you have questions, just put it on Scrambler. I can take that. These two videos is all you need to do. So this is just what I did together with you. And if you watch this video, this will make you almost 95% graduate in everything machine learning that is going behind the scenes. This is a good blog which explains the math and how it is done. So that is the other one. And then if you're curious, you can watch all the videos of how this transformer gets to LLMs, then how GPTs, how attention works, how memory in LLM works. These are 4 more videos. Now you know a little bit about transformers. Transformers allows you to do scaling of self-attention. They have this idea of attention, which allows you to figure out, given a set of words, which word are important and which words are not important. And when it does it, it can do it in parallel. And that allows it to predict the next word faster or more accurately. That's pretty much it. That's all you need to know, learn about transformers.